Welcome to part one of how to create a Nano mouse. Before I begin, we're going to go over the different parts you're going to need to make your mouse. You can find all the hard to find parts listed on my website with a little parts list that shows you where to purchase them and about how much they should cost. To begin with, you're going to need a small breadboard, some 2x5 female headers, of course an Arduino Nano, a 9-volt battery. I suggest the one listed on my website because it's rechargeable. It's a lithium-ion battery that's rechargeable and delivers 500 milliamps of power. Very unique battery. You're going to need a battery clip that's a 2.1 millimeter on one side and 9-volt on the 9-volt clip on the other. You're going to need a breadboard voltage regulator kit. And when you solder it together, make sure you follow the instructions to make the right side pins positive. You're going to need some 22 gauge wire that you can use to create jumpers. I recommend 3 colors: black for negative, red for positive, and some other color for a signal wire. You're going to need 4 rubber bands, a tacked switch, 6 3/8" long number 4 sheet metal screws, 8 1/2" long number 4 sheet metal screws, some continuous rotation servo motors. I recommend the parallax servo motors. You can see I've already taken the arms off. These screws just hold the arms on. You're going to need some wheels to go with these servo motors, and wherever you pick up these motors you can probably pick up these wheels. You're going to need a ball caster, and of course you're going to need the frame, which the designs are available on my website. The first step is to attach the servo motors, and that is done simply by putting them in place and using the 1/2" long sheet metal screws. You may be tempted to modify some standard servo motors. There are instructions on how to do this on the internet. I recommend against doing so because standard servo motors will not perform as precisely or as nicely as servo motors that were designed to be continuous rotation servo motors. So although you may be able to do it a little bit less, more inexpensively, that will come at a cost. Also, you'll want to make sure not to tighten the screws too much. Just snug. That's all you need. If you do anything tighter, you're going to ruin the frame, which takes a couple hours to print. Once you have your servo motors connected to your robot, it's time to put on the wheels. Slide right on. Then use the servo arm screw to hold them on. Once your wheels are on your robot, it's time to add the ball caster using the 3/8" sheet metal screws. Once you have the ball caster screwed to your robot, it's time to lay it like it's going to drive, flat on the table. And then we're going to put on the breadboard. And we're going to do so such that the blue side of the breadboard here, this blue side of the power rail, is on the left side of the board and the red side is on the right side. And then what I want you to do is super glue the 2x5 header pins in place. You're going to put a little dab of super glue here, and then right in the middle here, click it down and hold it, and that'll keep it from bouncing out. It'll make a nice firm electrical connection because the electricity pins are actually going to be these ones on the end, so the super glue is not going to interfere with them. I've actually already done this, so I'm going to replace this board with my prepared board. And the next step is to place the Arduino on the breadboard, and then my jumper wires. First I'm going to connect the positive to 5 volts on my Arduino Nano. Oh, sort of bent that jumper wire. There we go. And I'm going to connect the black wire, the ground, to the ground pin on the Arduino. So the ground pin on the Arduino to the blue part of the rail, the 5 volt to the red part of the rail. Next, I'm going to connect the tact button, tact switch, right here. I'm going to use a signal wire from the right side of that pin to pin D9 on my Arduino, and I'm going to connect the left side of that pin to the ground. If you're familiar with digital circuits, you may be wondering why I'm not using a resistor in this circuit, and it's because I am going to use the internal pull-up resistor of the Arduino. Next, it's time to attach the voltage regulator, like so. And then I'm actually going to remove the breadboard for just a moment so that I can attach some rubber bands to the frame. Once your rubber bands are in place, it's time to screw in the last 2 screws right on the bottom here. And you don't want to drive them in all the way. Just leave about 1/8 of an inch gap so that our rubber bands have something to hook on. Now I'm going to bend these servo wires down, put my battery in place, bend the servo wires back up, and then run my rubber bands across so that they hold both the battery and those wires in place. Alright, now it's time to place the breadboard back on the robot, and we're going to connect these servos using the male header pins, which will be connected to the black and red wires on the servo cable. I'm doing the left motor first, and it's going to go, the signal wire is going to go straight into pin D6, and then the right servo motor, again making sure that the male header is connected to the red and black wires, and this little yellow jumper is connected to the white wire. This is going to go right in front of that into pin D5. Alright, now I'm going to use a rubber band to actually hold the breadboard onto the robot. And this prevents me from wasting a breadboard should I ever decide I want to use this breadboard somewhere else. I don't have to peel off the stickum and make it a permanent fixture. Alright, and the last thing is to connect the battery clip to the voltage regulator. And we can actually test this one by turning it on, and running the program I have already preloaded on this Arduino Nano.